Today you're going to solve problems involving direct, inverse, and joint variation problems. So let's just talk about what you did earlier in the year. In Chapter 2 you studied many types of linear functions, and in this section you will be looking at a specific type of linear function known as a direct variation. Now, direct variation is a relationship between two variables, x and y, that can be written in the form y equals kx. Now, k cannot equal 0, and b cannot equal 0. If k equals 0, it takes away the x, and then it would just be y equals 0. Since b equals 0, the graph of a direct variation equation will always go through the origin. Now, let's talk about the constant of variation, which is k. So it is the slope of the direct variation equation. Now, if k is positive in a direct variation, the value of y is going to increase as the value of x increases. Okay, now you need to be able to write and graph direct variation. So we're going to look at an example here. Again, with direct variation, y equals kx. So you're going to need to solve for k. So here is the problem. Given y varies directly. So as you're reading your problems, you need to pay attention because we're going to deal with 3 different types of variation. If it says y varies directly, that's telling you to use this equation here. As x and y equals 27 when x equals 6. So we want to write and graph the direct variation. So we need to figure out what k is. Alright, so we'll just plug in the information. We have y is 27, x is 6, but we don't know what k is. And k is going to be our slope, so that's important. We need to find that. We just substitute those values in, and we divide by 6, so that's going to give us 27 over 6 for k, which we can reduce to 9 over 2. Alright, now we're just going to plug k back in, and we'll have an equation for our direct variation. So y equals 9 over 2. Notice that there is no b. b equals 0. So we're going to start at the origin, where x is 0 and y is 0. You'll make your point there, and then you're going to use your slope, which is k, and that's constant. So we're going to go up 9 and over 2, and then I also went down 9 and over 2, and then you can graph your line. Now, the phrase is y varies directly as x and y is directly proportional to x have the same meaning. And because of this, you can solve direct variation problems in 2 different ways. Now, last year you did a lot with proportions in geometry, so if that's more, if you like that way better, that's fine. So I'll show you both methods and you can choose which method you like the best. Okay, solving direct variation problems. Here's an example. The cost of an item in euros varies directly. Now, as soon as you see varies directly, you can replace that with equals k as the cost of the item in dollars. And E equals 2.85 euros when D equals $5. So when you want to find D when E equals 10 euros. Alright, you basically have 2 different sets of problems here. So kind of put together the first piece of information, and then usually you'll see the word find, and then there'll be a second piece of information. So this stuff goes together, and this stuff goes together. So we're going to solve this problem first in green. Method 1, we want to find k. So we know that when we go back up and read this, E, and then as soon as it says varies directly, you want to write equals k as the cost of items in D. So that is how you set up. You know, it's not always going to be y equals kx. You have to pull the information out of the story problem. So here it's E and D. So we're going to substitute the value for E, which is 3.85, substitute the value for D in the first set here, which is 5, and when we divide, we're going to get that k equals 0.77. So now we have what k equals, and now we want to find out what D is. So if we have 10 euros, we want to know what the equivalent is in dollars. So once we have k, and we have E, we can solve for D. So just substitute those values in. E equals KD. So we have 10 equals 0.77, which is what we found for K, times D. And when you solve that, you're going to get D equals $12.99. Or, if you would rather, you can set up proportions. Now, this would be the left side, this would be the left ratio, this would be the right ratio, and then you would just cross multiply. So you're going to use a proportion, and make sure, however you set up the left side of the proportion, you have to set up the right side. So don't flip-flop these. If you have dollars on the top here, you have to have dollars on the top here. This subscript just means your first piece of information. So all we have to do is substitute the values. We're going to put in the first set, we know the dollars is represented by 5. We know euros is 3.85. The second set of information, the euros are 10. And the dollars are D, what we're trying to find. So now you can just cross multiply, and you're going to divide, and you end up with the same exact answer. So again, this is what you did last year when you were trying to measure maybe across a pond of water, and you used similar triangles. All right, now we're going to go to the third type of variation, which is joint variation, and that's a relationship among three variables that can be written in the form y equals kxz, where k is the constant, so same thing, of variation, and you can say that y varies jointly as x and z. Now this is in 3 dimensions. This one we're not going to graph, we are going to graph the other two. So solving joint variation problems. Now here's our example, and I wrote a few things in, so I'll just pull the paper down as we go along. The volume, so when you have joint variation, you have y equals k, x, z, and quite often you're not going to have y, x, and z in your story problem. So as you read your story problem, just kind of circle what information you have, and again, when you see varies jointly, you want to write in equals k. So the volume, I know that's going to be one of my variables, of a cone varies jointly, so that means equals k, and jointly means y equals kxz, as the area of the base, so that's another variable, and the height, which is h. So now I know that my equation is going to be v, because that's here, varies jointly, equals k, as the area of the base, which is b, and the height. So here's my direct variation. I have 3 variables and k the constant. Okay, now we have 2 different pieces of information. We have the first set of information, which is in yellow. I have the volume, the base, and the height. I have the second piece of information where I need to find the base. I have the volume and the height. So first I need to find out what k is, very similar to when we were doing the direct variation. Okay, to solve joint variation problems, first find k, then use k to solve for the missing variable. So step number 1, find k. We have v equals k times the base times the height. So again, we're going to use just the first piece of information. So we're going to substitute these values, 12 pi, and you can put your units in if you want to, times k. Our base is 9 pi, and our height is 4, and that should say feet there. The units are left off. So we're going to solve, just simplify this side, which is 36 pi k, divide each side by 36 pi, and we have k equals 1/3. Now we're going to go to step 2, where we're going to use the variation function, and we're going to use k now that we have it. And the second part of the problem says find b when v equals 24 feet cubed, and you need to add in, and the height is 9 feet. Okay, so we're still going to go back to v equals k bh. All right, so our volume for the second problem, so we're done with this. Our volume for the second problem is 24 pi feet cubed. K is 1/3. We're looking for the base now. We don't have that. And the height is 9 feet. So we're going to simplify this side just to make it 3b. We'll divide by 3. And our base is 8 pi feet squared. And the base is the base is length times width, so that's why our units are squared. All right, now we're going to write and graph inverse. So this is our third type of variation. Inverse variation is a type of variation in which one quantity, and you need to insert an N there, one quantity increases as the other decreases. So it can be written in the form of y equals k over x, and again, k cannot equal 0. Now sometimes you may see it like this. And here you can see that this number has to stay constant, so if x goes up, y has to go down. And the other way around, if y goes down, or x goes down, y has to go up, because this has to stay the same. So if you have, let's say, 2 times 6 equals 12, and if we make x go up, we have to stay at 12. Let's make this go up. 3 times 4, this one has to go down to stay at 12. All right, the equation is read y varies inversely as x. Now, when you're graphing inverse functions, try to choose the values of x that are factors of k so that the y values will be integers, and that might make a little more sense here when we actually start graphing. So, here's our example. We have y varies inversely as x, and y equals 4 when x equals 5. So we want to write and graph the inverse function. Okay, now, inverse function is y equals k over x, or you can do xy times k. Which is the same thing here, because if you multiply both sides by x, you're going to get xy equals k here. All right, step number 1, y equals k over x. The information that we have is y equals 4 and x equals 5. So we're going to plug in 4 and 5 and find that our k value is 20. The second step is we want to write the variation function. So when we write the variation function, remember that x and y are going to change depending on where you are on the graph, but k is going to stay constant. So we only fill in the value for k. So y equals 20 over x. All right, then you're going to make your table. Now, when you're making your table, you want to try to choose factors of 20. That way you're not graphing decimals and fractions. So there are several factors of 20. Now, inverse variation graphs, you need to graph negative values and also positive values. So you're going to have two tables for each side of your graph. And here I'm choosing negative 10, negative 5, negative 4, and negative 2. Those are going to be negative x values. And then when I choose my positive values for x, I'm just going to make these all positive. So it's going to be 2, 4, 5, and 10 positive values. And then when I substitute 2 into here, 20 divided by 2 is just 10, 20 divided by 4, 20 divided by 5, and 20 divided by 10. So that's going to give me my values for my graph. Now your graph is going to look like this. You're going to have an asymptote, or a line that you can't cross over, right here, because x cannot equal 0. And the reason x cannot equal 0 is because x is in the denominator. All right, so just a reminder that you want to find k. It will remain constant. X and y will change depending on where you are on the graph.